Hey, so today we're going to talk about an ideal gas, or the concept of an ideal gas. Notice I said the concept of an ideal gas. Ideal gases do not exist. Do not exist in nature, but it's basically how do gas particles behave. So we have three different things. First thing, ideal gases, particles move in a straight line. There are no attractive forces between the particles. In other words, if two particles get close to each other, they're not going to go and be attracted to each other. And third, because they are moving in a straight line and there's no attractive forces, they're just going to keep moving until they hit something. So they technically have no volume because they keep expanding until they hit their container. Now I told you that ideal gases do not exist in nature. So what happens is in order for a regular gas to behave like an ideal gas, you have to have a very low pressure. That means if there's a low pressure, the gases can keep expanding outward and outward and outward and theoretically have no volume. In addition, they need to have a very high temperature. And this high temperature is going to cause them to move so fast that they're just going to keep expanding. Now the last thing I want to tell you, excuse me, and you're going to find questions like this on the Regents and in your practice. But all gases, 1 mole of a gas equals 22.4 liters. That's established. That is how much a mole, or how much volume a mole of a gas should have. Now that doesn't matter if it's neon gas, if it's hydrogen gas, or if it is water vapor, whatever. Doesn't matter how many particles of each you have. 1 mole of this equals 1 mole of this equals 1 mole of this as far as the volume is concerned. So 1 mole of any gas is 22.4 liters. Practice problems. Peace.